Nonlinear systems of equations, example number 2. All right, these aren't lines, right? They've got squared in them. Now, as I mentioned earlier, it's not imperative that you understand the underlying graphs. I always feel, though, that that helps explain why we got these different types of answers. Now, we didn't spend a ton of time on this. We didn't have a lot of time to do it. But when both variables are to the second power, it's either a circle or an ellipse. That top equation turns out to be a circle because not only are both variables squared, but these coefficients are the same number. All right? So, again, you don't have to even understand any of this graphing discussion to do the question. I'm just trying to set the stage for the behavior of this system. When they're both squared and they have different coefficients, it's as if that circle got smushed a little bit. It's now an ellipse. So we're dealing with a circle and an ellipse. And one potential picture would be that they cross each other in 4 different places. And there's tons of other pictures that we could draw as well. The math is going to lead us to the correct situation. It's possible they hit each other in 2 points. It's possible that they don't even touch each other at all. Maybe the ellipse is contained entirely inside the circle. There'd be no solution. There's a ton of different scenarios that could explain the behavior of this question. The bigger issue is how to actually solve it. And I would hope from our previous discussions on assignment 28 and 29 that you would think that elimination makes the most sense here, because we've got our variables lined up. Recall that substitution requires y equals or perhaps x equals. And lacking that, and I don't even think, well, okay, should we flip something here? All right, anybody? Which one? Are we going to get rid of x or y? Thank you. Oh, okay, well, that's a little bit better. Somebody give me a quarter here. Let's get rid of x or y. Should we? Okay, heads is x, tails is y. All right, it's tails. I lied. It was actually heads, but I want to get rid of y. Okay. Let's get rid of y. I stacked the deck. All right. Because look, 4y squared, 2y squared, that's easy to get rid of, isn't it? So hopefully, looking at that, you would have said, let's leave that bottom equation alone and leave it positive 4y squared. And let's just manipulate the top one so as to become negative 4y squared. Therefore, we'll distribute negative 2 on that top equation. We know how to eliminate a variable. This time we're getting rid of y squared. So, positive 4y squared, and this becomes negative 4y squared upon distributing. So negative 4x squared, negative 4y squared, and negative 80. And we're going to get rid of y squared. Eliminate y squared. You know how to eliminate a variable. I got faith in it. I haven't graded your papers on this yet. I'm recording this before you've turned anything in. But I think you can eliminate a variable. People before you have. You're fine. I'll stop. All right, so that's negative 1x squared, otherwise known as negative x squared. Look at that, we got rid of y squared. Elimination. And this is negative 16 over here. Now, I could click the link back to quadratic equations if you wish. Don't make me click that link. But I hope you would understand that we can use the inverse operation approach now, because this equation only has x in one place. So let's right? In the order of operations, you do exponents before you multiply, and that negative out there represents multiplication by negative 1. So step 1 would be to divide the negative 1, leaving us with x squared equals positive 16, and then square root, square root. And now, this is easy to forget, but the square root of 16 is actually the square roots of 16, 4 and negative 4. So there are two values of x, 4 and negative 4. It seems like we're getting multiple points of intersection now. All right, so apparently one of those pictures up there is what's happening. And so hit pause, do whatever you got to do. I'm going to scroll this up here and write down x equals 4, x equals negative 4. Two different scenarios, two different values of x to consider. All right, so catch up, do whatever you got to do. All right. I would love to leave this up here and do the rest of the question way over here where you can't see me, all right? But obviously that wouldn't make sense, and I'm trying to make sense. So, x equals 4. I feel like a caged animal here. That's okay, we're making it work. I'm proud of everybody, hang in there. We're doing well, we're gonna make it. All right, this is our last assignment, get her done, all right? So, we want to find the y value for each of those x's. Pick an equation, right? And we talked about you can pick either one. I don't care. Top one is as good as any. We're going to plug 4 in there for x and find out what y is, right? Okay, so I pinned myself in a corner here again. Dang it, I should have... Board space, 2 times 4 squared plus 2y squared equals 40. I've chosen to put it in this one. Order of operations, exponent, 4 squared is 16. 16 times 2 is 32. And solve for y. You'll notice that the y is in one term. Inverse operations is where it's at on this one. How about we subtract over the 32? You guys know this. This is old stuff. If you were sitting in the room with me, and I wish you were, you'd be telling me these things. Now what? What should Mr. Sandcastle do now? Divide by 2! That's right, good idea. All right, and then y squared equals 4, and then square root, and it looks like y would equal plus or minus 2. So it turns out that that value of x actually pairs up with 2 different values of y, and we'll write this all up when it's all said and done. I guess I'll start writing my answers down over here where I have space. As I mentioned, I'm running out of space. What that should spawn for you would be the fact that x equals 4 actually produces 2, and then also negative 2. So when x is 4, y can either be 2 or negative 2. That's 2 points then. That one value of x has 2 different values of y that pair up with it. The other value of x, negative 4. We haven't looked at that yet. Same thing. We go put that into one of these equations. Let's do the top one, okay? So, 2 times negative 4 squared. By the way, this is going to be the picture. We're going to get 4 ordered pairs. 4 points. I'd love to leave it up, but I need room. Plus 2y squared equals 40. Same thing, solve for y. Well, let's clean up the numbers here. Negative 4 squared is 16. 16 times 2 is 32. As we're writing this down, you're hopefully like, wow, this looks really familiar here, this equation that's on the board. Sure feels like I've seen it before. Let's say your short-term memory isn't the best. I'm old, I don't know. Let's see, y is in one place. Inverse operations. Subtract the 32. What should Mr. Sandcastle do next? Deja vu. Divide by 2. Square root. Looks like the 2 values of y for that are plus or minus 2. Look, it was the same equation. I was pretending I didn't remember. Okay, so this value of x also pairs up with those 2 values of y. So again, I wish I could do it over there, but I'm out of space. So let's transfer that idea over here. When x was negative 4, we got 2. And when x was negative 4, we got negative 2. 4 points of intersection. The picture I had to erase up here, I probably could have left it. I see it still up there. Oh well. But 4 points of intersection. Curves can cross each other in multiple points. And that's what just happened. So that's example 2. And I think we're down to maybe 3 more examples. Just so you know, we're probably going to skip example 5 because it doesn't really do anything different than the others. So I think we're down this semester to examples 3, 4, and 6. We got 3 left. Let's cherish every moment together, shall we? Hope you're doing well.